Welcome to Astronomy Daily, your go-to source for the latest updates from across the cosmos. I'm your host, Anna, and today we're diving into some truly groundbreaking discoveries and significant developments in space exploration and astronomical research. From the Webb Telescope's first exoplanet discovery to private astronauts docking with the International Space Station, and even a fast radio burst traced back to a defunct NASA satellite, we have a lot to cover. So get ready to explore the universe with us. The James Webb Space Telescope, or JWST, has just hit an incredible new milestone. Since beginning its science operations in July 2022, Webb has primarily been busy probing the atmospheres of known alien planets, looking for signs of habitability. But now, for the very first time, Webb has made its own discovery, directly imaging and finding a brand new exoplanet. This groundbreaking find reveals a young system hidden within a swirling cloud of dust and debris, and the planet itself is the lightest one imaged so far, a truly remarkable accomplishment made possible by Webb's advanced capabilities. This recent discovery, detailed in the journal Nature, opens up an exciting new window into hidden, Saturn-like worlds. Now you might wonder, how exactly does Webb manage to see a planet that's so close to its incredibly bright parent star? It's a challenge because planets are many orders of magnitude fainter than their stars, and from our perspective, they appear incredibly close to them. Anne-Marie Lagrange, research director at the French National Center for Scientific Research and lead author of the paper, explained that when you look at a planet, you mostly just see the star. To overcome this issue, her team used a special attachment for Webb's mid-infrared instrument called a coronagraph. Think of it like recreating a tiny solar eclipse within the telescope itself. The coronagraph blocks out the overwhelming light from the star, making its much fainter surroundings, and any orbiting planets far more visible. Using this ingenious technique, scientists spotted a young planetary system, only a few million years old, named TWA-7. This system has 3 distinct rings, with one being particularly narrow and surrounded by 2 areas that are almost devoid of matter. In Webb's image, something lies right at the heart of that narrow ring, and the scientists concluded that this something is indeed an exoplanet. This newly discovered exoplanet, now dubbed TWA-7b, is more massive than Neptune, but about 30% less massive than Jupiter, making it quite similar in mass to Saturn. TWA-7b orbits a star that formed approximately 6.4 million years ago, and it maintains a significant distance from its star, about 52 astronomical units, which is 52 times the average distance between Earth and the Sun. Lagrange noted that this is also the first planet found that perfectly explains the gaps observed in a protoplanetary disk. Planets are born from the leftover material from a star's birth, which forms a swirling disk of matter. Previous observations of these protoplanetary disks have shown ring-like structures and gaps, which scientists believed were telltale signs of unseen planets. Until now, however, there were no direct observations of those planets. The mass and orbital characteristics of TWA-7b precisely match the predicted properties of an exoplanet that would have formed in the gap between the first and second rings of this disk. By using Webb to observe these young, faint planets, scientists have truly unlocked a new doorway into the discovery of alien worlds. As Lagrange puts it, in terms of imaging, this opens up the possibility of imaging Saturn-like planets. In the future, it will allow us to characterize the atmospheres of these Saturn-like planets that aren't heavily irradiated by their stars, providing invaluable insights into their composition. It's a huge step forward and helps us understand the complexities of searching for very light planets in these early stages of planetary system formation. In other exciting space news, a quartet of private astronauts has successfully reached the International Space Station. Houston-based Axiom Space launched its 4th crewed mission to the ISS, known as AX-4, lifting off on a SpaceX Falcon 9 rocket from NASA's Kennedy Space Center in Florida. The mission began early Wednesday morning, taking off at 2:31 a.m. Eastern Daylight Time. After what was described as a particularly long orbital chase, more than 24 hours between launch and rendezvous, the crew aboard the new SpaceX Crew Dragon, aptly named Grace, successfully docked with the space station on Thursday morning. Commanding the AX-4 mission is none other than former NASA astronaut and Axiom's director of human spaceflight, Peggy Whitson. Peggy holds the impressive record for cumulative days spent in space by an American, a number that continues to climb with this mission. Joining her is a trio of international crew members: Shubhanshu Shukla from India, serving as mission pilot, Polish mission specialist Sławomir Uznanski of the European Space Agency, and Tibor Kapu of Hungary, also a mission specialist. Upon their arrival, these three became the very first from their respective countries to journey on a mission to the ISS, marking a truly historic moment. The AX-4 astronauts are set to spend about 14 days aboard the orbiting lab, where they will complete a record number of science investigations and STEM, that's science, technology, engineering, and math outreach events. In total, they have over 60 experiments planned, more than any previous Axiom mission to date. Their return date will largely depend on the weather conditions at Dragon's splashdown zone in the Pacific Ocean. This will be SpaceX's second West Coast crew recovery, a shift from previous Atlantic Ocean or Gulf recoveries. Now for a fascinating and rather surprising development in the world of astronomy. Fast radio bursts, or FRBs, have been a persistent mystery to astronomers ever since the first one, known as the Lorimer burst, was detected in 2007. These quick, intense bursts typically last for mere nanoseconds, although some have been observed for up to 3 seconds. While their precise cause remains unknown, scientists have recently traced some FRBs back to their source, often finding them originating from neutron stars, leading to the theory that these bursts are caused by compact cosmic objects. However, a recent discovery has added a completely unexpected twist to this cosmic puzzle. On June 13, 2024, scientists at the Australian Square Kilometre Array Pathfinder detected a potential fast radio burst that lasted for a minuscule 30 nanoseconds. This pulse, with a bandwidth strong enough to temporarily eclipse all other radio signals in the sky, led scientists to initially speculate that it must have come from a distant cosmic source, as is typically the case with these powerful signals. But in a recent study, a team of astronomers and astrophysicists made a startling determination. This particular FRB did not come from a distant astronomical source at all. Instead, it was traced back to something much closer to home: NASA's Pathfinder 2 mission, a now-defunct satellite orbiting Earth. The study was led by Clancy James, an associate professor with the International Center for Radio Astronomy Research, or ICRAR, joined by a collaborative team from various institutions. The satellite in question, Relay 2, was launched way back in 1964 as part of a series of early American satellites designed to test communications technologies. While its predecessor, Relay 1, famously provided the first American television transmissions across the Pacific, Relay 2 conducted radio transmissions for about a year before ceasing operations in 1967, when its transponders failed. When the FRB was detected last year, the assumption was, naturally, a distant cosmic origin. However, subsequent analysis pointed to a source much closer to Earth. The team then used the Skyfield Python module, an astronomy program that computes the positions of stars, planets, and satellites in orbit. This program revealed that the Relay 2 satellite was precisely within the observed FRB's timeframe and position. The distance calculated between the ASCAP telescope and Relay 2 at the time of observation was 4,322 kilometers, which was remarkably consistent with the estimated distance of the burst. The signal was so strong because the satellite was passing directly over the ASCAP when the burst occurred, explaining its surprising clarity. As for what caused this burst from a long-dead satellite, the team quickly ruled out the possibility that Relay 2 had somehow temporarily come back online. Instead, they attributed it to electrostatic discharge, also known as ESD, a phenomenon observed with satellites in the past. This happens when electrostatic charges build up on a spacecraft until they discharge in a large, sudden burst. Another intriguing possibility is that the burst was caused by a charged plasma cloud resulting from a micrometeorite collision. These groundbreaking results could lead to new tools for studying FRBs and other signals, potentially even new techniques for monitoring the vast array of defunct satellites orbiting our planet. They also suggest that radio observatories searching for cosmic rays could now be capable of identifying nanosecond-scale FRBs, helping future surveys distinguish between genuine cosmic events and interference from local objects. It's truly a testament to how even the oldest space junk can still hold scientific surprises. Now let's turn our attention to some significant developments from SpaceX, where they're facing extensive rebuilding efforts following a recent anomaly, while also making impressive progress on new infrastructure. At their Massey's test stand, SpaceX is undertaking considerable repair work after a major incident involving Starship 36. During an attempted six-engine static fire test, an anomaly occurred, causing substantial damage to the facility. The immediate focus was on making Massey's safe, and crews have since been busy assessing the damage and cleaning up debris. While larger pieces of Starship 36 have been removed, cleaning the trench itself might take longer due to the static fire stand still being in the way. The damage at Massey's is quite extensive. The gantry that held the ship quick disconnect is a tangled mess, along with the liquid oxygen and liquid methane piping. All the vaporizers used to pressurize the methane tanks are destroyed, and at least one methane pump appears damaged. The static fire stand structure itself seems okay, but all its clamps and piping will need replacing. Inside the trench, the aft section and raptors are likely to have caused damage to the flame deflector. One of the items that will take the longest to replace is the control bunker, which was completely burned out. This structure is essential for operating the methane tank farm and the static fire stand. Additionally, a storage tent and shipping containers nearby were also destroyed by the fireball. Pieces of Ship 36 are scattered across Massey's for analysis. According to SpaceX's updates, the initial failure mode seems to be a composite overwrapped pressure vessel that was holding nitrogen in the payload bay. The root cause is still under investigation, and it could take some time to determine precisely what happened. It's fortunate this occurred on the ground, making the investigation much more feasible than if it had happened in space. As a result, no static fire testing of ships or flights are likely to occur until the root cause is identified and Massey's is repaired. Despite this setback, SpaceX is known for its resilience, and they anticipate this will only cause a short-term stand-down. They hope to fly the last two Block 2 ships by the end of the year. In parallel with these repairs, SpaceX is also making steady progress on new hardware and infrastructure elsewhere. At their Sanchez site, work continues on components for Launch Pad B, including booster quick disconnect hardware that might be sent to the launch site within the next month or two. Progress on Pad B is moving at a consistent pace. A new assembled flame diverter ridge is also visible, likely destined for LC-39A, which will need it in the coming months. While there was talk of a new gigabay foundation for a new building, that process hasn't started yet. Over at the launch site, incredible progress has been made on Pad B. The launch mount is installed, along with the final 2 water plate manifolds and some booster quick disconnect hardware. There's also significant progress on the ground support equipment structure known as the gantry, which houses the high-pressure, electrical, and main cryogenic propellant lines. The flame trench for Pad B is also seeing rapid development, with crews installing steel plates that will form its floor and ramps. This design means there will be no exposed concrete to damage, allowing SpaceX to fix cracks and damage by simply replacing plates or welding cracks on the walls. This pad is designed to use a massive amount of water, around 450,000 gallons per launch, flowing through the mount and flame deflectors to protect hardware from the heat of 33 Raptor engines during liftoff. This will ensure quick turnaround times between launches. To achieve this, SpaceX is using a different pressurization system than at Pad A or Massey's, utilizing 9 methane and oxygen turbopumps to vaporize liquid nitrogen before pumping it into the tanks, which then force water through the pipes. They've also begun digging the trench for the propellant lines that will connect to the tower. Recently, testing of the 8 liquid oxygen pumps already installed for Pad B's tank farm began, including flowing liquid nitrogen through them for operational checks and leak detection on the subcoolers. This marks a significant step towards getting Pad B fully operational. As for Pad A, it's currently sitting unused, awaiting either Booster 15-2 for a static fire or Flight 10, following the loss of Ship 36. Moving on, NASA engineers are currently working to fix an issue with the Neutron Star Interior Composition Explorer, or NICER, X-ray telescope. This vital instrument, mounted on the International Space Station, has temporarily halted its ability to track celestial objects due to a bad motor. NASA paused its operations on June 17th when the degradation in its tracking ability became apparent, though they haven't specified when it might resume. This isn't the first challenge for NICER, which has been in use since 2017. Back in May 2023, it developed a light leak when several thin thermal shields were damaged, rendering it useless during daylight hours. Astronaut Nick Hague installed 9 patches in January to fix the worst areas, but some light interference continued. Closer inspection revealed smaller cracks and holes, prompting engineers to reconfigure the telescope's measurement power unit, allowing it to resume normal operations on March 12th. However, additional damage to at least one thermal shield forced NASA to minimize daytime observations again in late May. Despite these setbacks, NICER remains a crucial tool. It measures neutron stars, identifies black holes, active galaxies, and other phenomena, and even helps map routes for future Mars missions. X-ray telescopes like NICER enable scientists to study and better understand extreme radio events in space. For instance, observations from NICER, along with the Nuclear Spectroscopic Telescope Array, were instrumental in assessing a rapid burst of radio waves from a magnetar in 2020, an event that released as much energy in a fraction of a second as our sun does in an entire year, producing a laser-like beam instead of an explosion. Scientists used these same telescopes to observe another burst from that magnetar in October 2022. That's all the exciting news from the cosmos for today's episode of Astronomy Daily. Thank you for tuning in and exploring the universe with us. This episode was hosted by me, Anna, and we hope you enjoyed our look at the latest in space exploration and astronomical discoveries. For more out-of-this-world content, visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and listen to all our back episodes. Subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts, and follow us on social media by searching for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Instagram, Tumblr, and TikTok. Until next time, keep looking up, and I'll be back tomorrow with another roundup of the latest in space and astronomy news. Bye.